All right. So, so until now, we saw how the database works. We have seen what are the different memory structures, what are the different processes, the need of those processes, what exactly they do in the background, and we also saw what are the logical objects and the physical objects in the database. Last class we saw about initialization parameter file, which is nothing but the p file, or it's also called as sp file if it is converted into a sp file. Right. So today we are going to learn something more about the processes in a database. So now when I say the processes, we are not talking about these background processes. Apart from these background processes, there are a few processes which come from outside of the database, which is basically say if your application is trying to connect to your database, then it has to come via a process, and that process becomes a session when it comes into the database. This one. So users or application connecting to the server where the database is hosted. So these are user processes. So every process needs a connection to get inside the server. So we'll read about what are the different ways these processes are uh, managed. Right. So in instance management, we have process management. So these processes which we saw, which comes from the application or the users, these processes can be of two types. One is called as a dedicated process, other one is called as a shared process. So what happens in dedicated process is every connection which is coming from your application or from the user has a um, dedicated process inside the instance. So what happens in this one is every connection has one process. So all if you have set the processes parameter, say in this one at the database level, so let me see what is the process parameter set for this one. Okay, so here my processes parameter is 400. All right, in this 400, say I say if there are 400 connections happening to the database, then all these 400 processes will be assigned to those incoming connections if I have a dedicated kind of a dedicated model for the process management. But if when I select a shared model, so what happens in the shared model is there is something called as a dispatcher. So dispatcher is nothing but a group of processes. It is kind of bundled virtually. So a group of processes, say when you set the dispatcher, for enabling this shared model, we have to set few parameters, after which the shared model will start enabled. We'll see what parameters are those. But what is exactly happening here is instead of giving one process for each connection coming, what they did was they said we'll bundle few processes, say for example 100 processes, we'll bundle it up and we'll give that control to something called as a dispatcher. Dispatcher is kind of a manager. So all the connections which are coming in, it will come to the dispatcher, and dispatcher will see which all processes are free. So and it will hand over that connection to that free process. Now the work of this process is over once it hands over that incoming connections from the client to the database. Once that connection turns into a database, it is free. It is not serving any purpose unless there comes some response from the database back to the user. So what basically I'm trying to say is if a user tries to connect and the user is able to get into the server using a process, then until the server finishes up its work and goes to the database, gets that information from the database, and then when this information is given back to the users, until that point of time this process is free. It is not doing anything. It is not using any, it is not doing any work. So what Oracle did was, instead of leaving that process free, in that time that process can be used to handle another request which is coming into the database. So that is what they did by putting the dispatcher. They bundled a bunch of processes, gave it to the dispatcher, and said dispatcher will from here on dispatcher will decide which process to use for which coming connection, and there is a small memory associated with that one which will keep track of which client used which processor in this set of processes, and which process should be used to respond back to the client when we have that required information ready. So this is not like a big concept as a DBA. It's a DB related skill, but this is kind of a one-time setup, right? So by default, you will have the dedicated kind of setup when you install a database. But if you want to set up a shared kind of model, then you have to set some parameters, and that would be one-time setup. You set it up one time, and that's it. You won't touch it again, right? Just the way internal communication is happening between the application and database, that will be changed internally, but as a DBA you won't see any difference in how the database will behave. So this is kind of an internal setup. There might be a question where in an interview, if they might ask what is the difference between dedicated and shared process management, right? So this is, if you just say that dedicated has a dedicated process, whereas shared, a dispatcher is there which bundles up the processes, and that will decide which client gets which process, and that will handle the process the process distribution and response. So
So
that is,
this dispatcher process has take all the requests like in on a timely first come first serviced manner. So it will collect it up and give one by one. That's how it works.
yes, as simple as that, yeah. So if client one requests a connection, it will see what process is available. It will use that process and transfer that information to the database. And once that is done, that process which it used, that is available for use again. Basically, kind of multitasking instead of leaving one process dedicated to the user. So the initialization parameters which are required for the shared server is shared underscore servers, max shared servers, shared server sessions, dispatchers, and max dispatchers. So shared services specifies the initial number of shared servers to start, and with a minimum number of shared servers to keep. So it kind of goes in a stage wise, right? You can set up like how many minimum processes do you want to start once the database starts. Say if you say you have 400 processes in your database, you can set up like, okay, start 50 processes first, and then if 50 processes are kind of completely used all the time, then increase that value by another 50. So that is what information this shared server parameters gives. And maximum shared server would be maximum amount of processes you can give. You cannot say if I put the shared servers at 50, and it keeps on assigning 50 each time, because the number of connections coming from application is more, it will use all the 400 process after assigning 8 times, right? So we cannot do that one. We cannot put the database at risk or the server at risk just because we want to serve connections to the application. So we can set a maximum shared server. Say maximum you can go 200, but minimum you go 50. So 50 to 200 you can either increase, reduce. So database will take care of that. Dispatcher and database will take care of that. And shared server sessions. Basically, this specifies the total number of shared server user sessions. So uh, after the connection comes into the database, right? Processes come into database. Once that is in the database, here also that shared process mechanism comes into picture, where it can use the shared sessions also inside the database. One session can be used for multiple purposes. So that is what it means. That is what the other parameter shared server sessions works for. And how many dispatchers you want to configure, like one, if you want to say, okay, one dispatcher can take care of 50 processes at a time, and you can say you can start more dispatchers, then that is also possible. You can increase the number of dispatches, and you can set maximum dispatches also. So these are the few of the parameters. Again, like I told you, this would be one time setup. If there is a requirement that we need to go with the shared server architecture, or if the application documentation which you receive when you are designing a database, and it says we have to go with the shared server architecture, that is how the application will be working fine, uh, because we have lot of connections just making a connection and just staying idle. So they think shared server is kind of beneficial. They will say that explicitly that the process must be a shared server process. Then you just set up these values. You will find documentation how to set up that one, so nothing to worry about that. Okay, so that is shared and dedicated server process. So these are few of the views which has all the information about the number of sessions and other information. So this is kind of most of it is at a higher level, at a performance level. So right now, for your understanding, V dollar session would be of use. Basically, what V dollar session will give us information is what all sessions are logged in into the database. Now, when the connection comes into the database, is sessions, right? So at the database level, if you want to see what all connections are coming in into the database, you can find it out from this view. So what all information does that view give? Let me describe that view. V dollar sessions. Sorry, V dollar session. Okay. So a bunch of values it gives, just to put in a easy way. Username, the user who is connecting to the database, application user or developer, or some other tester is trying to connect, that information will come. What is the status of the connection, whether it is idle, it is not doing anything, or it is active, it is running something, that information will be here. What is the process ID? Every process will have a process ID just to identify. Every session will have a session ID to identify. So what is the process ID? It will come here. From which machine has the user logged in? Every machine has a IP. Every machine has a name. So like our I don't know, command prompt will show me. Okay, not this one. Let's not go here, right? Every machine has a name. So what I mean to say is, like this machine, what is the name of this machine is localhost.local domain. So like that, every machine which is used for connection that has a name or IP address associated with that one, which will help us to understand which session, from where is this session coming from. Why will all this be useful? I'll tell you at the end of explaining this one. Which machine it's coming from, and what program is it running? Is it running a SQL plus program, or it is running a Java program? What exactly it's trying to run? That information will come here. And but from that, what was the logon time? When did the session login started? And along with that, this blocking session and this one, we'll read this later. Now I don't want to confuse you. We'll take a separate session for that. Apart from that, is that session waiting on something? How many seconds it's waiting on? Okay, on what wait class it's waiting on? Yeah, those are a few things which will help you understand what exactly this information, what exactly this view has information about. So at a SQL plus level, if I want to pull up that information, this is how it shows. I'll just say username, status, program, select username, status, program from $V session. So I have 42 sessions in this database which are active. You see the status, it is active. So it did not give me the username because these are all our background processes. Reco, SMCO, this is the checkpoint, log writer, checkpoint. All these are background processes. So this is running inside the database. There is no user connecting from outside. But these are active because database is up and running. That is why. Okay. So, or if there was an external, okay, probably this one here, it shows the user, right? Probably this is my connection. I connected from outside, right? Let me see. I'll open another terminal and let's see. So I made another connection, right? Now on the first terminal, I had 42 connections. If I rerun that query, now it's increased 43. So these are my connections actually. You see here, one is inactive. That session which I opened, that is inactive because I'm not doing anything on that one. This is my current session which is active. Both are connecting as sys. I did SQL plus slash as sysdba, right? It connect as sys, and it's a SQL plus connection, and it is coming from localhost.local domain. That is my current machine name. So this is how it gives us the information. Now, where will you use this information? That is the main question, right? When will we use this information? It will be useful when in a scenario where suddenly the system admins, the team which takes care of the servers, they say that there is a CPU usage which is going above 90% on your database server. So database server, if CPU usage is going above 90%, that is our work. We need to see what process is using more CPU, right? So in that case, first thing what I will do is I will use a command which is called as a top. So top command will give me all the current statistics at the server level, right? So this is my current CPU. Here you see percentage CPU. I'll show you, I'll explain you this top command when we go to performance tuning. But for now, this will give us all the statistics of the server right now. So here it is showing me the current CPU. US means user, how much CPU is the user using, how much CPU is the system using, and how much CPU is idle. So assume in that case where we got a complaint, here 90% of CPU was used by the user and 5% was used by system. So total of 95% of CPU is being used, and we don't know what is happening, who is using that CPU. In that case, what you will have to see is you have to see this percentage CPU here. It is continuously changing. This value is continuously changing because it is every second it is checking the values and updating this. So here you will see any one process which will be using more CPU. Here you see now this process is using 27% of CPU. Okay, so here you will see that process name which is, or the command name which is using more CPU. From that you will get this PID. PID is nothing but process ID. So you get the process ID. There are queries which you can use to convert the process ID, find the session ID from the process ID. For example, if I go on Google, query to determine session ID from process. No, not this one. So this one. So this query, if you run this query and it will ask you for the process ID, you give the process ID. Here you see the ampersand. Ampersand, whenever you see this ampersand, basically it is going to prompt you to enter a value. So when this prompts you to enter the value, give that process ID which you saw here. I'm not able to copy that command from there to inside this box, so I'm not able to run it. But once you give that process ID which you are interested about, it will give you the session ID. Once you have the session ID, you use this $v sessions, and you'll find out who is that process using, and what is the status, is active, inactive, who is the username who is connected to the process, and all those details. If it is a developer who kind of logged into the database to do some work, and he saw that and he ran some query, and that query was running longer, so he just said, okay, let it run, I'll log in once I reach home, and let me check. And he left that running, and that query started using a lot of CPU. Then you will know from this one that, okay, this is the guy who has logged in from this machine, and you will try to reach out to him, or reach out to his manager or his colleague or the team. You send an email and tell them that this session is eating up all the CPU, can you cancel that session? Okay, once they cancel that session, all the CPU usage will come down. So that is one of the work which you will be doing as a DBA during your day-to-day life. Those instances are very less, but again, when it comes, you should be ready to do what has to be done at that point of time, right? Because once CPU usage is more, it's kind of a panic situation. If it's a production database, it's a panic situation. So you have to be faster in those terms. But again, when you have all these queries handy, like this query, you found this query, you found it one time, go and keep it in a OneNote. I said scripts, determine session ID from process ID, and I save the script. Okay. So this, while you paste it, it will give you that link also automatically. So no need to worry about from where you got that one. So it will be there. And next time, whenever you have that kind of requirement, you just go to script and try to see what I need to look for. Select that query, run that query, and you have that information, right? So this OneNote comes very handy in such kind of scenarios. So that is where your $v session will be useful. There are many other sessions, many other views also, which will be useful as we go further, and we are in need of that information. I'll show you what exactly that can be done. Okay. Any questions on the processes? Was this $v session too much for you guys?
No, I don't have any questions.
Okay. All right. Okay. So next one is memory management. We kind of did a little bit in the last class about this one, where we saw about the SGA, PGA, and everything. But I did not know that there was a extra information in here. So I thought, let me finish it up today. So memory management. So memory is basically when you start a database, memory is assigned. You know that one, SGA and PGA memory is assigned. So for that memory, you set those memory in the parameter file. We know that one too. We saw it last time. So let me check once more what my parameters is for. Show parameter SGA. So this is my SGA size. Okay, SGA max size and SGA target. And we have show parameter PGA. Okay, so this is PGA aggregate limit and PGA target. So just to make you guys clear, what I will do is, so for memory part, right? Just memory in database, two major parts is SGA, PGA. Okay, in SGA we have many others like caches, whatever the caches we saw, buffer cache, read log cache, all those things are there. In PGA we have some memories related to for the programs which are running. Okay, so SGA is kind of the not one important. SGA has a lot of smaller memory components in it. Let me try to show you this. Yeah, right. SGA has so many small memory components. So for each memory component, you can set the size. So option one is set size for every memory component. So you will say my database buffer cache is equal to say 10 MB, redo buffer cache. I'm not giving the exact names, I'm just telling you what it is. Exact name of the parameter. So redo buffer cache, say you give 5 MB and all this one. This is option one. This is called as a manual memory management. Okay. So first is manual memory management, where you set size of every component individually. Okay. This can be done only when you know what exactly is your requirement. Okay, and this will be done mostly by experienced DBAs, senior most DBA, or the architect who is working in your company. You won't end up in this situation. Okay, option two. Option two is auto memory management. Right, in auto memory management, there are two more options. One is you set SGA and PGA size, right? You say SGA, say 4 GB, PGA equal to 2 GB. You give these values and your work is done. So database will determine what to set for the database buffer cache, redo cache, and all other caches. Second option is you set something called as memory underscore target, memory underscore target, and memory max target. Memory max target. Okay, so you set these two. Say you say okay, memory target you say 8 GB, and max you can go 10 GB. Okay, you set this one, and database will take care of what to set to PGA, what to set to SGA, and what to set to internal memory components. Right. So depends on how much freedom you want to give Oracle database to determine the memory component size for you. Okay. Generally, most of the places, this is what is followed. They set a SGA size, they set a PGA size, and they kind of keep control on how much memory can be given for SGA and PGA. But again, later on in the later releases, Oracle came up with this option where you don't need to even think about giving SGA and PGA, because people started complaining that how much should I give SGA? I don't know how to calculate all those things. There are ways of calculating that one, but it requires a lot of trial and error kind of process. Like you use a database, see how much SGA is being used, predict it, and then set it up. So it's kind of not a standard process. Okay, even though you have development, testing, and production environments, still it's not a easy process. So you have to do trial and error until you achieve a particular point. Okay, to avoid such kind of issues, Oracle came up like, okay, don't worry about SGA PGA, just set this parameter, memory target and memory max target. We will take care of anything internally. Okay, how much to give for SGA PGA, will take care, we'll decide depending on our internal calculations. So they gave the liberty to customer to just give one value for us, and rest all Oracle will take care of internally. So that is where the memory max target and memory target came into picture. So again, if you are designing a database from the scratch, then again your application document should have this information. If they don't have, just start with 4 GB or 8 GB of SGA and see how database behaves. If database is slow, application team is complaining, then try to increase it by 2 GB or try to find out what exactly the issue is. And if it's really memory related, then we increase the SGA and PGA size. Memory related, it will clearly say that I'm not able to get some memory, so I'm not able to assign memory, something like that. So one of the error which I was working today was 01048, I guess. 048. All the Oracle errors start with ora dash. Okay, ora dash, then there'll be a number. You'll slowly get used to that one. Okay, I forgot that number. Yeah, something 1048, where it was not able to assign enough memory to this where's that shared SQL area. So it was complaining in the alert log that I don't have enough memory to assign to the shared SQL area. And so we had to check why exactly it's complaining that one, and we figured out that there was fragmentation in memory. So we kind of set a initialization parameter suggested by Oracle, after which the issue was kind of gone. So many things come into picture. Few times, if you are not able to figure out, you can obviously reach out to Oracle support. They will have solutions for everything. So that is the memory management. Any questions on this one?
No.
Yeah. So how do we set the memory? Is all using the alter system set command. Okay. Any changes to the parameter, alter system is what is used if you are changing in a SP file. We'll do that later on as we start using our database. Again, these are few of the views which will give us the information about different uh, what is the SGA size and how the SGA being used, all those things. So that is it for today's class. I wanted to do the other installation.